The, I don't know. Last week something happened with the video. I don't know. So I don't know how to control what the end result will look like until after we're done it. And so I apologize for the. At least there's audio, and you guys can kind of follow along if there is a mistake. But I'm trying my hardest here to keep the video going. But yeah, today we're going to be doing the lymphatic system and a little bit of the immune system. Again, throwing a flat stone across a still lake kind of a thing. We're just kind of hitting little bits and pieces there. But other than that, I think we're all right. If you guys are good, are there any emergencies? Excellent. All right, and if there's anything going on, just shoot me an email. You guys know the routine. You guys are all good, and some good marks popping up there already. I've already seen. These tests are not designed to take you down. So, all right, let's go. Now I'm going to share my screen, and no, you don't want to do statistics. Okay, so here we are. If you guys are good, you guys can hear me. If there's any issues, just scream. But other than that, we're going forward. All right. Welcome to the lymphatic system. This system is Luke. I am your father. Sorry, I got a fan right here. So if it's too loud or you guys can't hear, I need that fan back on. But the lymphatic system is, how do I describe it? We haven't got to the cardiovascular system, the heart, the veins, the arteries. We haven't gone through that yet. We're getting there. The lymphatic system, though, is a system that kind of goes parallel to the cardiovascular system, the blood traveling around. And wherever you find an artery or a capillary, these kinds of things, which we'll get into more, I'll show you guys there a bit there today. But wherever you find blood flow, you will generally find the lymph system. And it's the whole premise there. Like the cardiovascular system is let's just call it a tube. It's just an enclosed tube where we'll start off at the lungs. You breathe in oxygen. The oxygen gets into the blood. The carbon dioxide gets out of the blood. And then the blood moves on. And then the blood moves to my big toe and then comes back again. It's a tube. It's an enclosed system. If you ever have internal bleeding, whoa, get to emerge now. Okay? Because blood is not supposed to be hanging around, having a coffee there outside of where it's supposed to be. All right? It's a tube. It's a system. Okay? Is it a perfect system? The body is pretty awesome. But as with any type of organic system there, it's not going to be perfect. And like I remember a million years ago, I worked at the Honda plant in Alliston. And this is, you're going to say it's completely unrelated. Just give me a second here. They make the cars there, the Honda Civic, and they spray paint it, and you think about all the extra paint and everything and all the junk, the oil, you know what I mean? This is nasty stuff, man. You do not want it getting into the environment. And at the Honda plant in Alliston, and basically at every single automotive plant in existence right now, there's a whole underbelly, a whole underside of the plant that you never see. There's a huge water system that travels around underneath the plant. And oil and water don't mix. Oil floats. on top of water. So they have this system of kind of canals underneath the plant that the excess paint and goo and goop and oil goes down under and collects it all and takes it to a special place so that it can be processed. Okay? In the same fashion, the lymph system is a backup. And the whole reason is, you see this pen I have here? It dropped. Why? Because of the gravity. Correct? Excellent. It works the same way with your blood and your fluids. Like we are 60% water, 70% water. Okay? And the whole idea is that water is still prone to the laws of physics. And the physics says that things... Sorry, I think there's a microphone on there, guys. I don't know who it would be. You just mute that. Thank you. Water is prone to physics. And where you guys are going, working with elderly people, you will notice, and maybe you've already seen this, that sometimes you'll see elderly people there. They will be wearing special socks. And they're tight socks, nylon socks, they're tight. Because the fluid that is being continuously pumped through your body, some of it, depending upon the strength of your heart. Elderly people tend to have not as strong hearts as younger people. So if the heart can't pump as strong as it used to, well, then that means there that some of that liquid, fluid, is going to remain in and around the feet, which is why people will wear special socks to keep that fluid moving. All right? And I've said to you guys there before, and I'll say it again, and I'll keep saying it until we get to the cardiovascular system, that your heart is only involved in pumping blood to where it needs to go. Your heart is not involved in getting that blood back to the heart. Okay? And we'll get into that. The difference between an artery and a vein, very different. They're both pumping blood, but different ways. And the blood gets back to the heart by your, what we call the skeletal pump. Your skeletal muscles that you have control over. That's how the blood gets back to the heart. If you're sitting around and you're not moving, well, you're going to have fluid collect in your feet because you're not moving. But if you're running around and jumping and moving around, and you don't have to be doing exercise, you can just walk to the store. And because you're moving, that is how the blood gets back to the heart. Okay? We're getting there. I'm just kind of giving you guys a totality here. But the lymph system is a system that runs parallel to the cardiovascular in a sense. Any leftover fluid that's kicking around, here now we have a system, just like at Honda underneath, that collects all this stuff and gets it to where it needs to go. That's the lymph system. Let's go. We're going to list 3 functions of the lymph system. Describe the composition and flow of lymph. Describe the lymph nodes, right? Here in the armpits and there in the groin. Axillary nodes and inguinal nodes. Okay, cervical, axial, and inguinal. That means the hip region. And we're going to describe other lymph organs, tonsils, thymus, and your spleen. Okay, so 3 main functions. Okay, bingo, returns interstitial fluid to the blood. So you have to think, you've got cells all around, right? Trillions of cells. And you'll have a blood vessel coming in, going right beside them, so that oxygen can diffuse, carbon dioxide can diffuse out. So wherever there's a cell, there's a capillary, which is just the smallest part of an artery. Okay, so you'll have a capillary, an artery, carrying blood right beside it. What happens though is that sometimes some fluid will get left behind in between cells. Interstitial fluid. Interstitial means in between cells, so it's kind of been lost and forgotten about. Well, that fluid's got to get out of there. It can't kick around there. So, returns interstitial fluid to the blood, absorbs fats and fat-soluble vitamins. Okay? Helps the body defend against infection. Okay? And you'll see here, just the analogy there that I was talking about, that if you're not moving around, you will get fluid. Okay, this is a bit extreme. This is actually quite horrible, but the point is made. Okay, and so it's just fluid building up due to gravity. It's got to get moving. That's why we need the lymph system. And you'll see here, first of all, what is lymph? So you'll see here that you have your arteries carrying blood. Okay, and I'm not gonna. Arteries are like this big. Okay, massive amounts of blood flow per minute through these things, right? Like you if you cut an artery, Jesus Murphy, get to the ER. Well, first of all, before you get to the ER, tie it off because it'll be right spurting. Capillaries are the shortest, the smallest part of that. And if you think of like the Mississippi River, it's a massive river, but then you'll have these little tributaries going off where it kind of slows down. And then you'll have tributaries off of that where it'll even slow down even more. And then at the end of it all, you have these little creeks, right? So you go back to the Mississippi. It's a roaring river, massive. Think of that as your aorta. Think of that as your arteries, fast moving, lots of blood. But eventually, the big river cuts off and diverges out into the land somewhere, and the water slows down and slows down and slows down, right? And at the end of the line, that's where you have capillaries. Okay, arteries, massive blood flow, very fast. Capillaries, microscopic. They are the only place where oxygen and carbon dioxide and nutrients can be exchanged in the cell. I apologize. I'm trying to tie these in. Okay, we'll get to cardiovascular, but I want you guys to know. Write this one down. Capillaries are the only place where oxygen, carbon dioxide, and nutrients are exchanged. Capillaries. Okay, so when you're looking at this right here, these are capillaries. Look, you've got RBCs in here. Okay, very, very small, microscopic. So at this level of the game, oxygen, carbon dioxide can be exchanged. And you will see, say you're carrying the oxygen, gas exchange is happening in here with the cells. All right, and then you'll see here that the blood has picked up the carbon dioxide and now is going back to the lungs. Venule, vein. Okay, lymphatic capillary. And you'll notice here that in the middle of all this that's going on, look at my lymph system. Okay, it's right in there. It's a separate system, but it's right in there, cleaning up the mess that the cardiovascular system has left behind. Is it a big mess? No, but it needs to be cleaned up. Now, what is this mess I'm talking about? Okay, it's called lymph. It's a clear fluid that kind of resembles plasma. Okay, and composed mostly of water, electrolytes, sodium, potassium, calcium, these kinds of things, even waste. Okay, left over there from the cells, cell metabolism. The cells are doing their thing. They may send a package out through a Golgi body envelope there. It might get lost. It might not. It's not a perfect system. Okay, And so lymph is this plasma-like solution there, water, salts, excess waste, even some proteins that leak out from the capillaries, okay, these kinds of things. That's like what would happen if the lymphatic vessels did not absorb all this stuff? Well, it would just get lost. And then there's infection, there's this collection. If you have all these extra proteins and fats and water just kicking around, they're going to interfere with normal bodily functions. So we need to get them out. That's what this is. That's what lymph is. Here's a nice little shot there. I really like this, the whole idea of the cardiovascular system. We'll get in there. There's your heart, aorta, coming around. Here's my big toe. You'll notice here, these are my capillaries. Gas exchange, nutrients exchange does not happen in the arteries. They're too big. There's too much blood. There's too much pressure. But going from the Mississippi to a smaller river, down to a little creek, that's where we are now. There's small pressure. Okay, it's very slow moving. And by the way, 60% of your blood at any given point in time is locked up in the capillaries. Okay, and so you'll see what happens here. What the lymphatic system does is it drains. It's basically a hole. Holy! Get out of the way. Fire truck's going. What this does is the lymphatic system, it's just basically a hole in the bottom of the bathtub. It's some place for the junk to get out of, some place for the lymph to get out of, okay? Drains the interstitial fluid, parallel to veins, okay? Every organ in the body has a rich supply of lymph vessels, okay? So it's a system there. We've all heard of the CVS, right? Cardiovascular system. We all heard of it. But not a lot of people are really aware of the lymph system. Okay, it runs parallel. The walls of the lymphatic capillaries are made up of single layers of epithelium. Okay, the large pore structures there, they drain the tissue fluid. Okay, you're going to see this word here, lymphatic ducts. Okay, once absorbed by the lymphatic capillaries, the lymph flows towards the heart through a series of... Now, getting back into this, the heart is responsible for getting the blood to my big toe. But it is not responsible for getting the blood back to the heart. That's where you've got to move. You've got to run and jump and live your life. You got to move around because it's called the skeletal pump. I'd write that one down too. Skeletal pump. All right. So if you're moving, the blood moves back to the heart. If you're moving, the lymph comes back to it gets reabsorbed. And you'll see here, you see the lymph from my big toe, there's a whole parallel system and it brings it back, tosses it right back into the blood so that the blood can take it to the kidneys or, you know what I mean, remove it or whatever. The blood will take it to wherever it needs to go, but it can't be kicking around in between cells. So that's what we're talking about here, all right? If you're moving, that lymph will make it back into the blood. If you're not moving, there's no skeletal pump. That lymph, if your heart isn't that good, it'll kick around by your feet. Okay? What causes lymph to move? We just did it. The skeletal pump. Okay? That's what's going on here. It's all part of it. Skeletal pump. That's what we're looking for there. The main ducts of where the lymph goes to. Now, this is going to be this is a good one here. There are only two drainage areas. There's the right lymphatic duct and the thoracic duct. Both ducts drain into what we call the subclavian veins. We'll get there. We'll get there, all right? And you'll see here that all the lymph from here, well, we'll show you here. The thoracic duct drains much of the body, shown in gray. So your thoracic duct is right in here, up by the heart. All lymph collected from here drains here. All the lymph collected from the right side here, the right upper quadrant, goes right here. Okay? So the right lymphatic duct shown in the flesh tone drains lymph from on the right side of the head, the right arm, these right here. So, okay, you got the right lymphatic duct and the thoracic duct. That's where the lymph goes back into the blood. Okay? These are really short chapters, by the way. Look, we're already halfway done. Okay? Lymphatic organs. Okay. We've got the lymphatic nodules. They're partially or non-encapsulated here. And generally, lymphatic tissue helps defend the body against disease. Okay, it filters particles such as pathogens, cancer cells, and will... Shire, are you okay? All right, you want mommy. Very good. I love it when they say that. Okay, good. Lymphocytes. We're going to get into these, okay, when we get into the immune system. Okay. The organs there that I want you guys there to focus on, we've got lymph nodes. You've got them all over the place. And generally where the lymph nodes hang out, it's all accordance to where we have holes. All right? Because holes, we need holes, but that's a place where pathogens can get in. That's a place there that we are susceptible as an organism to other organisms. So, to stop organisms from getting in through our holes, you see, we have lymph nodes in here, okay? Because we got lots of holes in here. All right, so if any bugs get in, and if they get into the blood, they get into the interstitial fluid somewhere, they got to go through the lymph nodes. Okay, and the lymph nodes there, that's where they have the lymphocytes there, and they'll chomp. Okay, anything there that's bad. You also have lymph nodes in here because your arms are interacting with the outside world, right? And there's more of a chance for them to get injured or cut or open there so bugs can get in. And let's say a bug does get in, well, it's not getting by my lymph nodes that are here in my armpits and my shoulder. Okay? You also have the same in your hip. Okay? Down, they call it there the inguinal. Okay? That's your pelvis. Okay, you got one on your, you got some on your right leg and your left leg as well. That if there's any infections there that come in there through the legs, they'll get stopped. Mucosal associated lymphoid tissue, MALT. Okay, and you guys can have a read of this there when you guys get a chance there. I'm sure you guys have heard of the thymus gland there. Secretes hormones called thymosins. These guys here, they promote the proliferation and maturation of special lymphocytes, which will the book may get into. So you guys can have a read of this right here. There's lots in here. You guys have the same PowerPoint, okay? The lymphoid tissue in many organs there are referred to as MALT. The lymphoid organs support the immune role of the lymphocytes. Now the lymphocytes there, those are the white blood cells. These are involved in infection fighting, which we'll get into there in the next PowerPoint. Okay, and what they do is they basically filter out the pathogens, even cancer cells. Okay. Lymph nodes, two compartments. There's lymph nodules and lymph sinuses. Okay. The lymphocytes and macrophages, immunity, and phagocytosis. Phagocytosis just means Pac-Man, chomp chomp. Okay. You have lymph sinuses. These are lymph-filled spaces. Okay. And you have a look here. What are the types of lymph nodes there? You guys we'll get into all three of them. You've got the cervical, the inguinal, and the axillary. We'll get into that. Why is the lymphatic system often the first site of metastasis? Aha! There are lymph nodes near every single cell in the body. Okay? So, and I just want to read this. So lymph nodes easily pick up cells shed by a nearby tumor. So, like just the whole idea, cancer cells, that's the whole thing with cancer cells. You only need one. And then it divides and now you've got a mess, right? Well, these things here are going to collect in the nodes. Okay? And that's a good way to find out what's going on. Go for the nodes and see. Here you go. Like you can see here, I'll blow it up a little bit. You can see here that there's a whole system. All right. Here is your right subclavian vein. Okay. Here's your left subclavian vein. Okay. That's where the blood comes for the both ways there for the blood to go, or the lymph to go back into the blood. And you can see here we have nodes all over our faces. They're all in there. All right? Because there's lots of holes here. And you'll see lymph is everywhere. And all the way down the feet there to get that sewer system moving. Okay? What else we got here? Here's your inguinal nodes, as I was talking about there before. That anything there that gets into here, it ain't making up into the torso. Okay, you have your axillary nodes up here in the armpits. Any infection there that was gained in the arms ain't getting into the torso. Okay. Let me zoom back here. What do we got now? The thymus. Okay, assists development of the immune system there before puberty. Okay. Secretes thymosins. Produces T cells, lymphocytes. I don't know if you guys have heard about T cells. These are the sniffer dogs that I think I was talking about there a week or two ago. These are the sniffer dog cells. And I mean that. They're sniffing every cell. They're not literally sniffing because they don't have noses, but they're reading every cell. Because you remember your cell membrane. Your cell membrane is not just a piece of cellophane, a piece of plastic wrap. It's got proteins and glycoproteins, sugar proteins, all sticking out of it. Okay? And the reason why cells have these glycoproteins hanging out the side is that for the lymphocytes, all right, next. All right, I see that you guys you have the right proteins. Okay, you can go next. And just the whole idea there, if there's a cell that does not have those glycoproteins there then all of a sudden, all the dogs are called, everyone's coming to the party, and whatever this is gets the chomp chomp. Phagocytosis, okay? So we'll get more into T cells, these kinds of things. What do we got here? The spleen. Okay, first of all, you can live without your spleen. You don't need it. But you do need it. And people who have the spleen is basically it's a blood sponge. That's all. That's what it is. And it houses there the well, here you have there's two types of tissue that I'll ask you about there for the spleen. There's red pulp, which is venous sinus filled with blood. Okay, so if you perforate your spleen, whoa, that means that there's going to be a heck of a lot of blood out into the body, which you do not want, right? The spleen is a blood sponge, all right? And it also contains a white pulp. Now, here are your lymphocytes, okay? These are your T cells and these kinds of things. So the spleen is very, very important as a kind of a blood reserve, and as well it houses there the T cells, also B cells as well. Okay, there's your storage of RBCs, and also is involved in removing old RBCs and platelets there. You'll remember there that the average age of an RBC is, I think, about 3 months, somewhere in there, maybe 4 months. Okay, I think it's about 90 days. And then, because RBCs do not have nucleus, so RBCs cannot divide through mitosis. So after about 3 months, the RBCs, they get the chomp. Okay. So the spleen is the largest lymph organism. I'm just reading here from the bottom of the slide. You guys can have a look at this there. It's located in the left upper quadrant. It is very vascular. Lot of tubes in there. Lots of blood. It functions somewhat like a lymph node. Okay. An overactive spleen may prematurely remove platelets, causing... I'm not interested in any type of disease name, so don't worry about that. Okay. I'm not going after diseases at all. Okay. If one happens to show up on the test, okay, all right, but disease is not my focus. I'll leave that for another teacher, even though disease is awesome. No, disease is not awesome. Learning about diseases is awesome. Excuse me. There we go. Yeah, you guys can read this there, but there's your spleen. What's important here? Red pulp, white pulp. C'est bon? It's good. Yeah, tonsils. You know that, right? Whenever you got sick, mom would check your tonsils, right? Well, there's a reason. Because if there's bugs kicking around, the lymph nodes are going to tell you, because that's where they're going to collect. Okay? And yeah, you guys could read about that there. There's your tonsils there. Yeah. You know. And here you go. And this is, you know what I mean? It's a short, this is going to be a short week. And actually, I like it because we have the test. That's kind of how I ordered this there, because you guys have your test going on right now. And I appreciate you guys making the trip over. All right. But that's it for lymph. Have a look at the chapter. Please read the chapter. And you guys have your questions there. You guys have your answers there for your study guide and all that. So perfect. And no break. Let's just get the second PowerPoint done, and then y'all are on your way. Perfect. Yeah. I see you, Amanda. Rock and roll. Okay. Okay, Laura, if you got to go. It's all good. I'm going to post this there to YouTube, and you guys are doing great. Get at it. All right, where's my chapter 21? All right, immune system. And again, I think this thing is like 20 slides. Yeah, it's not too bad at all. All right, so we'll ring this off, and y'all will be out of here by 1 o'clock. The immune system. Here we're down there, and the immune system is not something that was developed overnight by evolution. It's crazy. The whole idea that you are now immune from this organism, this pathogen, this bug, this whatever. And you have to think, you are the only thing that's conscious. Okay, man, we could get into, psychology and all this, and I don't really want to. But I'm conscious. My cells are not conscious. Right? They're like a calculator. They're just... But it's incredible how these cells, ingrained in their evolutionary development, are trained to recognize and remember something, a pathogen, a disease. And it's just incredible. It really is. Your body is adaptive. Your body is cutting edge. Your body is 2021. Your body is not 1999. All right? It's up to date, and it remembers. And that's why we've gotten this vaccine here. The vaccine there that you've gotten already, you remember you talk about those glycoproteins, right? That are on the outside of the cell. Well, here's your cell. Here's your virus. Your virus is like 1,000 times smaller. It's so small. The virus goes in, just commandeers the cell, completely takes over the steering wheel, and now this cell that was serving you is now being taken over by the virus. And then the virus uses the cell as a house to make more virus. But your vaccine, depending on which vaccine you've gotten there, but like the Moderna, what they do is they take the virus, they take everything inside of it that's harmful, mRNA or DNA, whatever virus you're talking about, and basically you've left with a husk of a virus. You've only got the shell of the virus. So that's what a vaccine is. It's basically the shell of a virus, and you see the virus comes into your body, and your sniffer dogs, hey, we've got an intruder. So what happens is now the body goes and attacks this vaccine and creates its own defense. The nice thing is a vaccine doesn't have anything bad in it. It only triggers an immune response from your body, which therefore from now until the end of time, you will have immunity to. And it's awesome. We're just getting there. We're just on the tip of the iceberg here. We're going to talk about non-specific immunity. We're also going to talk about specific immunity. Remembering. How do your cells remember a disease? Because maybe you got a disease, maybe you got chicken pox there 20 years ago. You're not getting it now because your body still has lymphocytes in there that they're sniffing around for chicken pox, right? And the reason why you don't have chicken pox anymore is because you probably got your vaccine there when you were a little rugrat. Okay? So we'll get into that. Non-specific immunity, specific immunity, targeted immunity. Let's go. We're also going to talk about we're going to differentiate between genetic and acquired immunity. You guys should kind of have an idea of what's going on here. Genetic immunity, where's that coming from? DNA. Acquired immunity, you interacting with your environment. Okay. We're going to describe naturally and artificially acquired. What am I reading here? Describe naturally and artificially acquired active and passive immunity. This is where we're at. Active and passive. We'll get there. We're going to describe other immune responses. Anaphylaxis. Anyone, an EpiPen. Anyone who has really bad, severe, life-threatening allergies. You carry around your EpiPen. Yep, I see you, Jennifer. Absolutely. Anaphylaxis. It's where your body overdoes it. And like my brother there, he lives in Oshawa there. It's dust and pollen for him. This is his worst time of year, man. He's just an angry old man right now. All right, but this is anaphylaxis. We'll get there. Autoimmune disease. These kinds of things. Body attacking itself. We'll get there. Good stuff. Yeah. Specific immunity protects against one thing. Specific, targeted. Non-specific immunity protects against everything that it can. So you have specific, targeted immunity, which is after one banana. You've got non-specific immunity, which is after all, which will protect you there from all the fruit. It's a horrible analogy, but I think it actually worked. Lines of defense. You've got non-specific and specific immunity. Your first line of defense, mechanical and chemical barriers. Can you think of any first line defense? Non-specific, so it's going to kill this bacteria. It's going to kill this bacteria. It's going to kill this virus. or at least stop it from getting in the body? Well, skin, right? Number one. And, we talked about skin there. Was that last week? No, that was muscle. No, it was 2 weeks ago. The whole thing there with skin is the second degree, first degree burn, not so bad, but a second degree burn, a third degree burn, get to the hospital ASAP. Because that's why there is a burn unit. Because if you've lost a whack load of skin, you're a sitting duck for bacteria and virus. So that your skin is mucho bueno importante. All right. That's an example of a mechanical barrier. You got hairs in your nose. Sorry if you don't like to admit it. Hair in your ears. Okay? These are mechanical barriers. Right? And they'll stop some of the dusts. Hello?
Sorry, that's me.
That's okay. Do you have a question, Joanne? No?
No, my computer was cutting in and out, so I had to do a reboot.
Okay, it's all good. It's all good. Hey, man, it's all good. You're back on, though. Perfect. Okay. The hair in your nose, hair in your ears, chemical barriers. Your stomach. Okay? Like the food that we eat. You may not like to admit it, but it's covered in bacteria. That's why we tend to cook things first, right? To minimize the amount of bacteria that's in our food, right? But anything there that goes into our stomach gets toasted because hydrochloric acid has a pH of around 2, and that will kill most things. Not all. So there's your mechanical and chemical barriers. There's a lot more, so second line of defense, phagocytosis. Chomp chomp. You ever wonder why let's say you get a cut, or maybe there's a little infection or whatever, and it gets all red. Why does it get all red? Why does a cut or an infection or even sometimes there you'll see contact dermatitis where you touch something, you don't even know what you've touched, and all of a sudden there's a little bit of a rash. Inflammation. That means that there's a problem, whatever the problem is, and everyone's coming to the party. And that's why there's a little bit of red here or whatever, because now there's a problem and everyone's coming to the party. And we'll talk about who everyone is in a bit. Fever. Like, one of the things there, like whenever you guys have a fever, please follow your doctor's recommendations. All right? But you got to be careful with... Tylenol in great amounts is actually very bad for your liver, so be careful with that anyway. But any of those types of anti-inflammatory drugs, okay? So it stops the inflammation, right? Now, and also these anti-inflammatory drugs like ibuprofen and Tylenol and these acetaminophen and all this, right? They're anti-inflammatory, which tends to also mean that they're anti-fever. All right? Bring the fever down. A high fever can kill you. More so in children, right? So we want to keep those fevers down, But you have to think the body is making you have a fever for a reason. And bugs don't like it hot. Okay? You got a bacterial infection or some type of infection. Well, what the body does is once the body realizes that, it's under attack, all right, kick it up 20%. And now all of a sudden everything starts to speed up 20%. So what does that do? It gets things to where they need to be that much faster. And it also kicks up the temperature. And the bugs don't like it. All right? So that's why the body does it. So you got to be careful. If you're taking an Advil or an acetaminophen, if that's what your doctor says, then please do it. But you got to question if you're taking an Advil. If you've got a normal fever, like I don't mean a normal, if your fever isn't life-threatening, then maybe do you need to take it or not? Because your body is fighting these bugs off. And if you give it an anti-inflammatory, what you're doing there is you're forcing the body to drop its temperature when the body wants to kick it up a bit. Now, again, I'm just throwing ideas at you. Please consult your physician, and for crying out loud, don't sue me. All right? So there we go. What do we got here? Specific immunity. Now, this is targeted, right? And this is for specific diseases. These are the watchdogs, the sniffer dogs, your B's and T's. They're on the watch. They're reading those glycoproteins on the cell surfaces of every cell, making sure that there's no infection. Right? It's targeted. It's acquired. Where did this information come from? Well, you probably had this disease before. Okay? In some way. Maybe you were exposed to this disease through the actual disease, or maybe you were just exposed to it through a vaccine. But whatever, these two here, they're on the watch. Okay? Yeah, you guys can have a look at that. This is a nice little slide here. I blew it up. So non-specific immunity, lines of defense. So these are non-specific. So they're not really after anything in particular. They're just after everything. So here's your first line here of your skin, your mechanical barrier. Okay, as we said there, your chemical barriers. Good one here. Your tears actually have an antibacterial ingredient, a lysozyme. And your tears, they have an antibacterial. So there's another example of a chemical barrier. Reflexes, another line of defense, right? Right? Getting out of the way. We move, somebody throws a ball at you, your arm just goes up and you actually catch the ball before you've actually realized that you've caught it. Those are your reflexes. That is beyond your control. They're there to help you. What else we got? Phagocytosis. There's your Pac-Man. Okay. Inflammation. Okay. Everyone's coming to the party. And that's what swollen means. The next time, something is swollen, that just means that your second line of defense is now concentrated here in your thumb, and there's a battle being waged right here in your thumb. And that's why it kind of feels tender. That's why you feel pressure, because there's more stuff there than there should be, because the stuff is fighting other stuff. Good. There's your fever, your temperature. Okay, so these are your second line of defense. And what do we got here? Protective proteins. And we've got our T cells right here. And that is a completely and horribly inaccurate picture of a T cell, but we'll keep it. Good. Harley, you okay? All right. Second line of defense, phagocytosis. You remember that word? Chomp, chomp. Okay, leukocytes. They go to the site of infection. Have a look at these words here. Follow up with them there. Leukocytes there. Chomp, chomp. Eat. Pathogens. And this is a good one too. They're not just involved in just eating bugs. They'll, stuff left behind, cellular debris, these kinds of things. Okay. Sorry, just going back here. So describe the process of phagocytosis. You guys can have a look at that. The phagocytic white blood cells. Phagocytic white blood cells. Those are your B's and T's. Okay. They must go to the site of infection by following a chemical trail. So generally, your B cells and your T cells, they're floating around, kind of located in your lymph nodes, all right? But they're floating around and they're sniffing and all that kind of stuff. But when there's an infection, let's say I just cut my finger right now. Well, there's really no white blood cells there, okay, at the moment. But what happens is this: some cells there, what they'll do is they'll see that there's a problem, and they'll send out a chemical signal. And then all of a sudden there, the T cells and B cells, whoa, we got a problem. So then they start to migrate. And some of these guys can actually jump through arterial walls. They can go through an arterial wall to get to where they need to be. It's awesome. Okay, so you guys can have a look at that there. There's some words there. What else we got here? Inflammation. There you go. Redness, heat, swelling, pain, these kinds of things. Increased blood flow. Okay, causes redness and heat. Okay, injured tissue leaks fluid into the interstitial space, causing swelling, which presses on the nerve endings to cause pain. Okay, in addition to infection, what are some causes of inflammation? Okay, irritants, poison ivy, all these kinds of things. So that's that. There's irritation, inflammation. Fever, pyrexia. We've talked about this already. Body temperature rises. Okay. Most pathogens are happy at normal temperature, so an elevated temperature will take some of them out. And this actually goes into aspirin. Therefore, a fever is treated with aspirin. But be careful. Maybe these anti-inflammatory drugs maybe not what your body's looking for. I don't know. Very good. Protective proteins here, we have what's called interferons. Okay, they are secreted there by cells infected by a virus. So once a cell has been commandeered and taken over, as a last resort, kind of like a suicide kamikaze mission here, as this cell is on its way to being self-destructed, okay, what it'll do is it'll produce these interferons, which now protect other cells. It's sending a chemical signal there to the other cells. Hey, I'm done for, but here, you guys protect yourselves. And this cell, either through itself or a killer T cell, will get the chomp. So therefore, the virus stays in that cell and it gets the chomp and doesn't infect other cells. So that's the whole point of an interferon. What do we got here? The second line of defense here, this is for the killer cells here. A lymphocyte that acts non-specifically, and it's effective against many microbes and certain cancer cells. So you have a look here. I don't know if there's your first line of defense. Oh, it's like, here's all of your invading enemies. Nice. Okay, I thought there was a crab. No, that's cancer. All right, very good. So here are your enemies. Here's your first line. Here's your second line. And here's your specific immunity here. Okay. You see that word there? Antibodies. All right. So these guys here are not after anything in particular. They're just trying to keep everything out. But once something gets in, here are these guys here, they take over and they are targeted immunity. Okay. So here we are. We're into this targeted immunity, the third line of defense. And the lymphocytes there are the T cells and the B cells. Okay. The T cells there, the killer T cells, they're cell-mediated immunity. The B cells there are antibody-mediated immunity. Antibodies, these are what we're talking about there for sniffing the dogs, or sorry, sniffing the cells, reading the cells. Okay? They're reading every single cell as it goes through. And if it doesn't catch it this time, it'll catch it next time. Okay? And you guys, the T cells and B cells, I'm just reading from the bottom here, which you guys can do the same. You guys have the same PowerPoint. They're lymphocytes that engage in specific immunity. T cells comprise 70 to 80% of the blood's lymphocytes, so it's mainly T cells and about 20% Bs. Okay, but Bs can be mass produced as well. The T cells engage in cell-mediated immunity. They attack pathogens directly and literally punching holes in them. You punch a hole in a bacteria, what's going to happen? All of its insides are going to flow out. So therefore now that bacterium is dead. That's what these killer T cells do. And they're actually reprogramming them now. I think in the past 10 years they've been on this. What they'll do is they'll take your own T cells, take them out of your body. They'll put them into a cell culture, where they will turn them into these ferocious beasts. And then they inject them back into your body. So now you have these ferocious third line of defense that are just, and they're using these because they have this kind of specificity to them. They're actually targeting cancer cells. And I really hope that this one works, because there's really no risk of any type of bad stuff, because it's your T cells. If they take your cells out, turn them into ferocious beasts, and then inject them back into you, should be good to go. Still waiting to hear on that one. So, you have a look here. Step 1, what have we got? T cell activation. Step 1, origin, maturation, seeding. Okay? These happens there in the nodes. Okay? Now, step 2, an antigen presentation. So here you have the pathogen. Here you have your macrophage. It's going to get a chomp chomp. All right? And then you see now this pathogen that was eaten, what the cell does. You know, the whole idea of an interferon there trying to send a message. If the cell chomps something that is dangerous, what'll happen is it'll dismantle this and send some of it out to the membrane. And you know those glycoproteins again, right? That'll be on these glycoproteins there. So when the killer T cells, they come around, they smell these. They can see these. All right? And they know that something's wrong. So therefore now you get this cytotoxic message. These cytokines here. And you see now you've sent a message. So now let's go. Everyone's at the party. We need our army because we now know that there's an infection. Okay? And yeah, fun stuff. I know you guys are probably nutty busy. You know what I mean? Oh, sorry, I guess you have a test going on right now. But if you get a chance there during the week, have a read of this chapter. You know what I mean? And if you don't have time to read, at least go, you guys better be reading the chapter summaries. Okay? But this is a good one. It's kind of complicated, but it's really good to understand how immunity works. And you see his memory T cells. Through chemistry, these cells are able to remember how to fight this disease. Even a disease that you haven't seen in 30 years. These guys will still be floating around your blood. Awesome. Antigens and lymphocytes. There's a slide in 2 slides there that we'll get into that kind of explains this a little better, but I'm just going to read this and move on. An antigen is a substance that stimulates the formation of an antibody. An antigen is a substance that stimulates the formation of an antibody. Generally large molecules, proteins, all right? But a few are these polysaccharides and lipids. So glycoproteins, okay? Sugar, saccharide, proteins, all right? So you got T lymphocytes and B lymphocytes. Although both come from the stem cells in the bone marrow, they differ in their development and function. T cells and B cells, very differente. Okay? Okay. It says here, refer students to table 21.1 for T's and B lymphocyte formation and function. So please have a look at that one. Okay? Cell-mediated immunity. T T cell function, the T cell activation there, we've got the macrophage ingest antigen, chomp chomp. The antigen presentation. So you see that cell just digested that pathogen, but maybe the pathogen is still it's still a problem. So what the cell then dismantles it and puts markers on its membrane. This cell is dead already, but at least it can send a message out to other cells, okay, by presenting these antigens, okay, on the outside of it, so that other cells will know that there's a problem. And also, when these antigens are presented, the body has the ability there to make antibodies, which will then chomp chomp. All right, it's a really, really good chapter, and this is important stuff. And I hope you guys all go on and be nurses and nurse practitioners and you know what I mean? I want you, and you guys are going to have to know this anyway. All right? And it's good stuff. It's a little chemistry, you know, and but it's not anything there you guys can handle. You may not think that you have learned a lot, but I tell you, you guys have learned an amazing amount in 5 weeks. All right? Keep going. Look at your terminology. You guys know all these words now, or are getting there. All right? What do we got here? Cell-mediated immunity. Okay, same thing right here. Okay? And what do we got here? So you got the origin, maturation, and the seeding, the same. Antigen presentation. So chomp chomp. Now we put these the antigens out here. Okay? So you have a look here. These guys here are my sniffer dogs. They see there that there's a problem. And again, the cytokines come up, which sends a chemical message. Whoa, we need the army. Cytokines. I like that word. You'll see it again. What do we got here? Antibody-mediated immunity, B-cell function. The B-cell activation. Macrophage ingests the antigen. It's kind of the same thing. Okay? The B cells and helper T cells are then activated. Like these B cells, we can make 1 billion of them in 2 minutes. They are always on call, and we can make more of them if need be. And if we don't need them, we're not making them. But if there's a need for them, let's go. Let's make them up. So that's what we're talking about here. And you'll see here, they do make clones. Okay? Have a read of these. This is all good stuff. These antibodies. Now you remember your antigens, they're on your cell membranes. Okay? And if there's a bad antigen, I shouldn't say bad, but if there's an antigen that is indicating that this cell is in trouble, okay, the body will make an antibody. Okay, and you'll see here, antibodies destroy antigens directly and indirectly. Okay, so an antigen stimulates formation of antibodies. So if there's a problem, the body will make antibodies. The antibody, which is secreted by B cells, are also called immunoglobulins. I used to be. Why can't I say immunoglobulins? Thank you. Why it's so difficult. Antigen-antibody interactions. You know the whole idea that we all know our blood types, A, O, AB, all these kinds of things, right? The whole process of taking a person's blood and putting it into yours, everything's got to be a match. Because if it ain't a match, what happens is you get somebody else's blood that is not compatible with yours and you put it into your body. What's going to happen there is your antibodies that are here running around, sniffing everywhere, are antibodies, and you just put in all this blood that has these antigens that your antibodies don't like, what's going to happen is all these antibodies in your body are going to tackle this blood and just turn it into mud. So now you've got a liter of mud in you. How do you get that out? You don't. So this is what happens. These immunoglobulins there, and they're specific, man. I tell you, they're like, this is the only thing that I'm looking for if I'm this particular type of immunoglobulin. And if I see it, I'm going to tackle it, and I'm going to turn it into mud. And then my friends are going to come help and clean us all up. But if you got a liter of someone else's blood in you, there's not enough cells in your body to help get rid of this. Okay, so it's a good little slide, and I mean it. Have some fun with this. You guys can get into these ones here. Okay, have a look at them, and as I said, we're not going heavy. Like basically with today's, I hope you guys aren't mad that I put in 82 questions. I think that they should flow pretty well. Like there's some easy ones, there's some tough ones, and there's probably a couple there that you curse my name about, but it's all good. It's all good. I can handle it. But you have to think there that pretty much every PowerPoint, if I continue to do 80 questions a test, that means that somewhere between 15 and 20 questions will come per PowerPoint. These PowerPoints here are kind of short. They may be less. So, yeah, these ones really aren't anything there too much today. But we're kind of skimming the surface here. What do we got here? Why is secondary response stronger than primary response? Interesting. First exposure. Second exposure. Hello. What's up, Nat? Sorry, I'm talking like Darth Vader. I can't. I'm teaching. So, I'll be done in a couple minutes, Nat. Give me a minute. So, what do we got here there? The initial response to an antigen is called the primary response. Okay, the primary response is associated with a low plasma level of antibodies and a slow development of antibodies. So this is your initial response to an issue. Okay, the secondary response, though, this one here is a quicker response and involves a larger number of antibodies. The reason is memory cells. All right. So your first one is kind of slow and calculated because it's the first time I've met you, pathogen. So I'm going to slowly tackle you and slowly dispose of you. And then we've now disposed of it. If that same pathogen comes back again, wham! It's not even close. It's just taken out and eradicated immediately. Why? Because of memory cells. Okay, they're already on it. So we've got genetic. There is inborn and species specific. So there are diseases that are they're species specific. But in this day and age, this is where we have trouble with this. Because we're getting heavier and heavier into the biotechnology field. Biotechnology is the genetic manipulation of microorganisms. We're experimenting on animals, all these, I don't even know. And it used to be that viruses and pathogens, they were species specific. Like my dog got the common cold. Well, that's a common cold for canines. It ain't mine. So my pooch is sick, I ain't getting it. Well, it's not the way of the world anymore. I don't want to freak y'all out. But you guys have seen these. Chicken flu. You guys remember swine flu? Was that 10 years ago or however long ago it was? And these are viruses that species specific, but for some reason, man, they mutated and now they can come after us. And how do you acquire immunity from a virus that's never existed before a human virus that's never existed before because it just mutated from a pig. And this is this. Immunity. How do you get these things? There's natural, there's artificial, okay, and genetic diseases. I'm gonna hold off on genetics for right now because when we do sexual reproduction, the male female, the organs there, we do cover genetics. So I'll kind of leave all that genetic stuff there for later. But yeah, immunity can be acquired through living your life, or you can have immunity from your mom. Okay, and genetically, through over the course of millions of years of evolution, there we can become immune to these things. Naturally acquired immunity. Active, you are exposed to the antigen and you produce antibodies. Okay, exposure to a virus. Passive, somebody else makes antibodies from mommy. So I will get you on these two. They're pretty cake, just the whole idea of two types of immunity. There's active immunity and there's passive immunity. Active is you in your environment. Passive is through your mom or some other indirect method. Artificially acquired immunity. There's active and passive again. Vaccines. Toxoids, don't worry about. Vaccines for sure. As your example there for active immunity. Passive, we've got immune globulins, antibodies made by others. Okay. Anti-venom. I like that one. That's a good one. I don't know if anyone's had a chance to watch 72 Dangerous Animals on Netflix. Great. Lots of venom. Lots of venom. It's actually not very gory at all. It's actually good for the kids. All right? And I got a 7 and a 4-year-old and they love it. So enjoy it. Allergic reactions. Oh, yeah. Occur in about 48 hours. Okay, they generally tend to be, this is the delayed allergic reaction. Okay, it can happen in about 48 hours. And one of them there, very simple, we've all had it. It's called contact dermatitis. Derm, skin. Okay, itis means problem. So contact dermatitis is where we've touched something. I don't even know what it was, and I've got an inflammation here. I've got an allergic reaction. Okay? Don't know from what, don't know from where. And you'll see here, usual cause is exposure there to skin, household detergents, poison ivy, this kind of thing. Another delayed response there is the activates there the T cells, causing the skin eruptions and inflammation. There's your contact dermatitis there. So we don't really know where it came from, but these are delayed allergic reactions. Okay, immediate, reactions. Okay, this is where you can get like anaphylactic shock. Okay, so an allergen activates a B cell. Okay. The activated B cell forms a clone of antibody-searching plasma cells. So here, we're starting to target this. These plasma cells secrete large amounts of antibodies against this allergen. So the plasma cells were made by the B cells. The B cells are alerted to the allergen. B cells are alerted to the allergen. The B cells make these clone plasma cells, okay, that are making antibodies. Okay? These antibodies are now going after this specific allergen. That's it. All right? And these antibodies there, they bind to mast cells. Okay? And mast cells there, they're involved in allergies, okay? They produce histamines. Now, anyone there who is very allergic to something, what happens is your body senses this something and starts making histamines. Histamines are these things there that make your nose go red and your eyes water, because if your eyes are watering, no bugs are getting in, right? If your nose is watering, no bugs are getting in because mucus and your tears are all coming out. That's what that's what histamines do. They flush, they clean. But then they also make life very miserable because you're sneezing and you got a runny nose and your eyes are all red and life sucks. So that's why we take, what's it called? Benadryl, antihistamines? Antihistamines. To stop your body from freaking out over a little bit of dust. That's how these go. So, interesting. Okay, have a read of this. The chapter's pretty good on this, and again, this is you guys have seen my test too. Generally, I'm looking for more generalities. I'm looking for common knowledge, but then I will pick something specific. So generally, no, you don't need to go too deep with this stuff here, but you guys have the slides anyway. So, where are we at now? Allergic reactions. Okay, and it's kind of the same thing of what's going on here. Activation of B cells by the allergen or the antigen, right? Okay. Production of these these are the plasma cells there. All right. And which then produce the antibodies. So this is basically a cartoon of what we just did right here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there are your antibodies. Okay. These antibodies bind to mast cells, and then binding of allergens to the antibodies on mast cells with the release of histamines. And you'll see here that these histamines, see if you can see this word. I like this word. It's a medical word. You don't see it anywhere else. Vasodilation. Anybody who has a puffer. Vasodilator. Vaso means opening. Could mean vein, could mean capillary, could mean airway. Okay? And dilation. Opening. We need more air, we need more blood through, or we're just opening it up. Okay? The opposite of vasodilation is vasoconstrictor. So in some cases there, we want a tighter airway, a tighter vein, tighter artery. What else we got? Other immunological responses there. We've got the autoimmune diseases develop in response to self-attack or autoimmunity. Organ rejection. There's a whole nother ball game. Somebody gets a liver transplant or something like this. Recipient's immune system recognizes donated organ as foreign. It starts to attack it. That's why generally anyone there who's had any type of a transplant, what they'll do is they take immunosuppressant drugs. Because these guys here, if you have a new liver, these guys here are going to be on it like a duck on a June bug, I tell you. So therefore, they take immunosuppressant drugs, which then knocks these guys out. Not completely, but knocks them out so that they are not going to take out your new liver. But the problem is, though, people who take immunosuppressant drugs now, they're more susceptible to other pathogens now. So it's kind of a two-sided coin, right? You got to go with the new liver if you need it, but you just got to take it easy. Yeah, a duck on a June bug. Yeah, my grandmother, Edith Bergen, she passed away there 2 years ago. She was from Owen Sound. Like, Owen Sound is my roots, right? And so, I tell you, man, miss you. But that is what we've got right there. That's the 2 slides. It's not too bad. Go and have a read of the chapters and try the questions. And other than that, you guys are doing good. Other than that, if you guys have any questions, out you go. And if you do have any questions, stick around. But other than that, get out of here and go and get your test done. And enjoy your day. And what's happened to my...